to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55.
Wow, I get chills every time I see that.
Me too.
Amazing. All right, so we know you have questions, so please continue to send them to us using the hashtag AskNASA. But before we go any further, I've got a question for you, Jim. Why is the mission called OSIRIS-REx? It sounds like a new hybrid kind of dinosaur or something.
It does, but it's actually the name of an Egyptian deity, a bird deity, but it means all the stuff the mission's going to be doing. So we're going to be searching for clues to the origins of our solar system chemically, looking at how we can ground truth all the data we have for asteroids from Earth, other spacecraft right up close with samples. We're going to look at the resource potential of asteroids, metals, hydrated water and hydrated minerals, and also consider security of our planet from these kinds of objects. It's a big name with a big mission with many things it has to do. It's multiple missions in one.
Yeah, 3 missions in one, in fact. We know we have a global audience for this event, and throughout the morning we'll be taking questions submitted via social media. So let's take one now. All right, what do we have? At S4Mule_B asks, what's the significance of studying asteroids like Bennu for advancements in planetary science?
These are literally the time capsules of the early solar system with those bits and fragments we can never get here. So we go and bring them home to connect ourselves to the place we live, our solar system. So that's one of the big takeaways of this. We will read the clues of Mother Nature on how our world works in the context of all the rest of the planetary system.
Fantastic. All right, let's take another question. What do we have? All right, from at Endanger817. Approximately how large is the sample size, and what kind of analysis will be performed?
So it's about 8 or 9 ounces. It's about a size of a baseball and a half, and the kind of analyses are amazing. There are toolkits and instruments that can look at nanoscale characteristics that you wouldn't imagine. We could see the hairs on a foot of an ant, but we'll look at those in the context of another object in the solar system. So, wow.
Wow, indeed. All right, we'll be taking some more questions throughout the morning. Okay, so let us head back to the ellipse to talk to Sophia. I understand, Sophia, you've got a critical team member with you. Take it away.
Thanks, Lauren. Yes, I am joined right now by Stu Wiley, who is the Oscar, or on-scene commander, of this recovery mission. Thank you for joining me, Stu.
Thanks for having me, Sophia.
All right, so you are the person who kicks off this whole process before even the recovery team gets on the ground. Can you walk us through your process?
Yeah, so essentially what's going to happen is that once the capsule is undershoot, we'll have a better idea of where it's going to land on the range. And based on that, I'll know exactly what kind of weapon systems we used in that area, what kind of tests we've done in that area. So I'll know better what kind of hazards are in the area. Once I land on the ground, I'll do an initial sweep of the area and methodically move towards the capsule and mark any kind of hazards that I find, whether it be munition hazards, of course, and or the industrial hazards, and even the environmentally sensitive areas that we have out here. So.
All right, and how did you prepare for this today?
So preparation has been in the process for a long time. Between myself and Jasmine Nakayama, we've got 40 years worth of explosive knowledge. Most of it is on this range here, so we know the ranges very well. The team and the UTR have been working together, both Lockheed and NASA, and we've been doing rehearsals so that we are more familiar with their capsule, and they're more familiar with our terrain here as well. Yeah, so.
And this is an active proving ground here. So what are the other steps that we have to ensure that our teams are safe?
Yeah, so at the Utah Test and Training Range, we do have a lot of different hazards out here. Like I said, the weapon systems that we test. We're going to keep them safe from that. We have, again, done many of the preparations with them already. They've taken safety briefings. They've been briefed on the actual items that we've dropped out here in their range safety brief. One of the hazards that we're going to be dealing with, though, is the helicopters that you see behind us, and they've been through practices getting on and off the helicopters and working in and around them. But I think the biggest hazard that we're going to have is slipping. We had some recent rain, so that I think is going to be our biggest hazard, but it could be fun too. So.
Well, wonderful. I know that you have your last preparations for the day, so I'm going to let you go, and thank you very much for joining us.
Thank you, Sophia.
Thanks, Sophia. Stu's got a big day today.
Oh, my goodness.
A lot to do. All right, Jim, we know we have space fans from all walks of life all over the world. One super fan in particular is a well-known astrophysicist with an atypical side hustle. But I'm guessing you know him probably more from his side thing than his science thing.
Well, that's right. He's literally space royalty and rock royalty. Perfect for a mission to bring back rocks.
Just a true rock star. Let's let him speak for himself.
Hello NASA folks, space fans, asteroid aficionados. This is Brian May of Queen, as you know probably, but also immensely proud to be a team member of OSIRIS-REx. I can't be with you today, I wish I could. I'm rehearsing for a Queen tour, but my heart's there with you as this precious sample is recovered. Happy sample return day, and congratulations to all who worked so incredibly hard on this mission. Especially my dear friend Dante, with whom we already created this beautiful book. God bless you all.
Speaking of rock stars, joining us is NASA's Lori Glaze, Planetary Science Mission Director. Welcome, Lori.
Hey, good morning.
Great to have you here, Lori.
Great to have you. And you and Jim go back quite a ways, right?
Oh, yes. Jim and I actually go back several decades, but we've been working together closely for many, many years, and it's so good to see you here. What an exciting moment.
Lori.
Thank you.
It is a really exciting day. So OSIRIS-REx is part of a larger autumn for asteroids, Asteroid Autumn, as we've been saying. Can you talk about some of the other missions that are happening this fall?
Happy to do that. It is really exciting. We have lots of asteroid missions, and actually 4 of them have major milestones coming up this autumn. Right on the heels of the sample return happening today. In 2 days, on September 26th, is the 1-year anniversary of a little mission you may have heard of last year called the Double Asteroid Redirection Test, demonstrated for the first time humanity's ability to deflect the path of an asteroid. How cool is that? And then coming up on October 5th is the launch of a mission called Psyche, going to visit a special asteroid called Psyche also, which is one of only about 9 of asteroids that we think are made primarily of metal, have a very high metal content, iron and nickel. And then about a month after that, on November 1st, is going to be the first asteroid flyby of our mission called Lucy, which will ultimately visit Trojan asteroids that lead and trail Jupiter in its orbit around the sun. But in November, we'll fly by a main belt asteroid called Dinkinesh.
Wow.
Wow, check that out.
It literally is an asteroid autumn. But Lori, one other thing, OSIRIS-REx, is a multi-purpose mission, all this great stuff you mentioned, and one of its key jobs is to help us with planetary defense. How does it do that way out there?
So actually, OSIRIS-REx gave us some really important new information about an effect, a force that occurs on asteroids called the Yarkovsky effect. And what that really is we know there's gravitational pulls on the asteroids, and we can predict that with our trajectories, but Yarkovsky effect says that the sun's radiation heats up one side of the asteroid, and then as the asteroid rotates, the radiation radiates off into the deep space. And that actually kind of acts as a force that kind of pushes back against the forward trajectory. And so it changes our predictions on where the asteroid might be. Over time, it really makes a difference. And OSIRIS-REx gave us some fantastic new measurements on that effect.
Unbelievable.
Wow, that is truly unbelievable. Nobody appreciates the Planetary Defense Axe-Fest more than me and Jim.
Yeah, we want to be safe.
Big fans, big fans. Really, really quickly here. This isn't the end for OSIRIS-REx. What's next?
Yeah, so really exciting. Now that the spacecraft has released the capsule successfully, about 20 minutes after that release, we're now repurposing the spacecraft for a new mission called OSIRIS APEX, where APEX stands for Apophis Explorer, and it's off on its new mission to explore the asteroid Apophis, which is going to have a close flyby of Earth in 2029.
All right,
Lori.
Stay tuned, everybody.
Unbelievable.
That is fantastic. Well, thank you so much, Lori, for
Thanks,
joining
Lori.
us. You're going to stick around for the show, right?
Oh, absolutely.
Absolutely. Okay. This will be the biggest U.S. sample return since the Apollo mission to the moon. But this is not the first time that anyone has captured a piece of an asteroid. On the arrival of the historic OSIRIS-REx sample, we celebrate that the Japanese Space Agency, or JAXA, has already visited 2 asteroids, Itokawa in 2005 and the asteroid Ryugu in 2019. The missions Hayabusa and Hayabusa 2 proved that it could be done and paved the way for today's ambitious goals of this daring enterprise. All right, let's send it back over to James for an update on mission operations. Go ahead, James.
Yeah, thanks, Lauren. So everything continues to be nominal. I've been tracking the mission status here. Everyone looks dialed in, ready to go. You saw a few moments ago Sophia with Stu Wiley, our on-scene commander. He's ready to go. He understands the mission. They are ready to get out and recover that sample today. And as I mentioned earlier, just a few moments ago, actually I guess a couple hours ago at this point now, the SRC was released from the main OSIRIS-REx spacecraft. When that release took place, it was given an initial spin, which kind of preserves its angular momentum, its speed as it's coming in to Earth's atmosphere. It's similar to throwing a perfect spiral on a football, and teams are hoping for that perfect touchdown today. What you're about to see is basically the equivalent of throwing a touchdown pass over 10 football fields away and landing it perfectly in that end zone. So you can see on your screen now the mission operations team. They are just next door, dialed in, ready to go. They've been monitoring the vitals of the SRC all morning. They've been there in the room, prepared and ready to go. I'm sure they are absolutely thrilled for this moment. They might even see themselves on the screen there in a second, but they are hype and ready to go. This is the Lockheed Martin team just a little bit north of us in Waterton, Colorado. They are also dialed in. They're the ones who gave that initial command this morning to release the SRC from the main OSIRIS-REx spacecraft. You just heard from Lori that OSIRIS-REx is now on its way to its extended mission. OSIRIS APEX visiting that near-Earth asteroid Apophis. A lot coming up in just a few moments. We're going to hit that key milestone of entry, descent, and landing. 13 minutes of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range. A lot coming up in just a few moments, but for now, back to you, Lauren and Jim.
Thanks, James. Very soon, NASA's Artemis program will be bringing us more cosmic samples to study by visiting a familiar beacon in the sky. Give us 60 seconds, and we'll give you the moon. Artemis 3 will be the first sample return mission of NASA's Artemis program, sampling rocks and regolith from one of 13 candidate regions on the moon, all located near the lunar South Pole. The Apollo lunar landers returned a treasure chest of samples that taught us about the history of the solar system, dating back about 4 billion years ago. Artemis missions will explore areas near the South Pole on the rim of the moon's oldest basin, the enormous South Pole Aitken Basin. Artemis will explore areas nearly 1 billion years older than those explored by Apollo. Lunar samples from Artemis 3 and future missions will help scientists interpret the impact history of the moon and Earth, as well as increase our understanding of planetary processes. OSIRIS-REx, the first U.S. mission to collect a sample from an asteroid, will return samples from asteroid Bennu. The rocks and dust collected will offer generations of scientists a window into a time when the sun and planets were forming over 4.5 billion years ago. Samples from OSIRIS-REx and Artemis could rewrite our understanding of the evolution of the solar system. And that's a look at your Artemis Moon Minute. Boy, Jim, how can you not get excited about that?
Oh my gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward